JEE MAIN 2026, 6th Apr Shift 1, Physics Question 38. Let us draw the setup. We have a thin semicircular ring of radius r equal to 35 centimeters. The half ring carries a uniform total charge Q distributed along its length. We need to find the electric field at the center of this half ring. A thin half ring of radius 35 centimeters is uniformly charged with a total charge of Q coulombs. If the magnitude of the electric field at the center of the half ring is 100 volts per meter, find the value of Q in nanocoulombs. Given epsilon naught equals 8.85 times 10 to the power minus 12 and pi equals 3.14. The key concept is deriving the electric field at the center of a semicircular uniformly charged ring. Consider a small element dl at angle theta. The linear charge density lambda equals Q over pi r. Each element produces a field D equal to kdq over r squared directed toward the center. By symmetry, horizontal components cancel. Only vertical components add up. Integrating from 0 to pi, we get E equals Q over 2 pi squared epsilon naught r squared. Step 1. We use the formula for the electric field at the center of a semicircular ring. E equals Q over 2 pi squared epsilon naught r squared. Given E is 100 volts per meter, R is 0.35 meters, epsilon naught is 8.85 times 10 to the power minus 12, and pi is 3.14. Step 2. Rearranging for Q, we get Q equals E times 2 pi squared epsilon naught r squared. Let us compute the denominator piece by piece. Step 3. Now substituting the numbers. Pi squared is 3.14 squared, which gives 9.8596. R squared is 0.35 squared, which gives 0.1225. So 2 times pi squared times epsilon naught times r squared equals 2 times 9.8596 times 8.85 times 10 to the minus 12 times 0.1225. This gives approximately 21.40 times 10 to the power minus 12. Therefore Q equals 100 times 21.40 times 10 to the minus 12, which is 2140 times 10 to the minus 12, equal to 2.14 nanocoulombs. The correct answer is option 1, Q equals 2.14 nanocoulombs. JEE exam tip, for continuous charge distributions, remember these key electric field formulas. For a full ring, E at the center is 0 by symmetry. For a semicircular ring, E equals Q over 2 pi squared epsilon naught r squared. For a quarter ring, E equals root 2 times k lambda over r. Always use symmetry to cancel out components. Like and subscribe for more JEE MAIN solutions on MAGPIEHUB.